we'll be taking programming, system programming. It's called system programming and Java. We are going to be running up with the system programming aspect today, and in the next class we move on to Java. Move on to Java. So first of all, I want us to quickly do a recap of what we did in the last class. A quick recap to refresh our learning process. Basically, I want to quickly do that in 5 to 10 minutes. A system, we talked about a system. Talking about a system. A system is, we said a system is a set of interacting or independent entities. A system is a set of interacting or independent entities. Okay. Then we looked at what we call the system programming, and we said the system programming is the writing of system software. And then we went on to the encompassing the definition that says system programming involves designing and writing computer programs that allows the computer hardware to interface with the programmer and the user, leading to the effective execution of application software or application system. Okay. Then from there we went on to look at the system program and application program. We looked at the differences between the system program and the application program. Then we talked about the basic 5 differences between these two. Then we went on to look at the application program, discuss about the application program. We said the application program is a comprehensive, self-contained program that performs a particular function directly for the user. So definitely what we're saying here is that what we said is that an application software is a program designed for the use of a user, to solve or perform a particular task. And then we looked at the various application programs. Then we went on to look at assemblers. I said an assembler is usually understood to be a translator which produces machine language, okay, which produces language code as output from an input language which is similar in structure to the output. And the only symbolic units of the assembly language or input correspond to the natural units of the computer of which the assembly is intended. Okay. Then from there we talked about translators. We said a translator can be viewed as a device which transforms an input string A into an output string B. So like I told you, I said that basically what it does is that an input string, so we have a work of saying, oh, a string of A is converted to a string of B. Okay, that is what the translator does. Then we looked at the compilation. We said it's a process the computer takes to convert a high-level programming language, such as COBOL or Fortran, into a machine language that computer can understand. The software which performs this conversion is called the compiler. Then we also looked at the interpreters. We said an interpreter is a language translator whose primary task during translation is to perform the actions dictated by the meaning of the statements of the language. In more concrete terms, we say interpreters read and obey the statements of language. So when the language is being written, basically what the interpreter does is to read and obey the statements of the languages. It reads and obey the languages. Then we looked at the uses of interpreters. We said simulation of real computers, simulation of hypothetical computers, interpretive compilers, simulation languages, and monitor system. Then we look at the difference between the interpreter and the compiler. Difference between the interpreter and the compiler, and we looked at the various differences which you can go through. I remember that I gave out my email address the last class, but I'll do that again. Let me just do that right now so that I can be able to send you the materials. There's if I'm to send you the materials ahead of the class, okay, especially ahead of the next class, which will be looking at Java. This will be an interesting class, okay. So let's move on. Today we'll be looking at tables, types of tables. There are basically two types of tables. We have the order tables and we have the unordered tables. So what do we mean by the order tables? The order tables, the easiest way to organize a table is to add elements as they appear without any attempt at ordering. Says the easiest way to organize a table is to add elements as they appear without any attempt at ordering. To add elements as they appear without, so that means that as elements appear, as they show up, okay, you organize them as they show up. You don't have, there's basically no need for you to say you want to start ordering the elements. So that's how it works. The elements are not ordered as they come, they are, you know, as they appear, they are being added to the table. Then the other tables, as the element comes, there is need for you to order them. Okay, so we say another table is one in which the first condition, in which an ordering relation is greater than or less than exists between any pair of arguments of a table. 2, the second condition, if Si represents the ith element of a table, then for all I and j, Si is greater than S. And 3, if and only if I is greater than j, or Si is less than Sj. If and only if I is less than j. So for you to have, for the other tables to be implemented with the elements, these 3 conditions will be considered in the ordering. So it's not like the another table where as the elements come, they are arranged in the table. These 3 conditionalities, 1 or 2 of these conditionalities will be met before the elements are added to the table. So the next person says the table is then ordered in ascending or descending sequence. So after it has been identified in a particular order, it's going to arrange it in an ascending order or in a descending order sequence. Okay. So let's look at utility software. Utility software is system software designed to help organize, configure, optimize, or maintain a computer. A system software designed to help analyze, configure, optimize, or maintain a computer. It is used to support the computer infrastructure in contrast to application software, which is aimed at directly performing tasks that benefit ordinary users. Now, what I would say there as regards to the definition of an utility software, what we say is that the utility software helps you to enhance the features or enhance the performance and the usage of a system. Okay, so we say it's designed to help analyze, configure, optimize, or maintain a computer. Now, let me give you a basic example of an utility software. Antivirus. An antivirus is an example of an utility software. Okay, so what antivirus does is that it helps to enhance the protection, of your system from viruses. It helps to enhance the protection of your system from viruses. So the new software, the antivirus helps to protect the provide security features for your system. So it enhances the security features of your system to prevent it from any form of virus. Another example is what we call a narrow software. A narrow software is used to burn files on CD or DVD-ROM. Now, ordinarily, you can burn a file on your CD-ROM or a DVD-ROM. You can burn a file, either text file, documents, video file, audio file. You can burn them. But when you use a narrow software, which is an integrity software, it enhances the way and optimizes the way you are able to burn files on your CD-ROM or your DVD-ROM. So it has other added features. It has other added benefits that we use to enhance and optimize the performance of your CD-ROM drive or your DVD drive. So it enhances the performance or optimizes the performance of your CD-ROM or DVD-ROM drive to be able to burn files of different types on your CD-ROM or DVD-ROM. Okay, so it enhances the performance, optimizes the performance of your system. That's what antivirus software does. Even your antivirus, every system, especially a Microsoft Windows system, has its own antivirus that comes with it. However, it may not be as strong as when you now install a basic and software and antivirus software on it, like the Avast, the Kaspersky, the Nero, the Norton, and the rest. Okay. So typically, a utility is smaller than a program in size and may be included with an operating system or installed separately. So what we are saying is that utility software are usually smaller than a program in terms of sizes, and this utility may be included with the system. So like this antivirus that comes with your Windows, some of them comes with it, and there are some that you will have to install separately. Like you now install Avast, Norton, Kaspersky, and the rest separately that does not come with your system. So these are the list of different types of computer utilities. Utility softwares. We have the antivirus, like I mentioned, the backup software, clipboard. Excuse me. We have the compression utility. You have the cryptography software, debuggers, DirectX. We have the disk checkers. We have the disk partition editors. Then we also have Dr. Watson, encryption tools, file manager, X editor, memory tester, network monitors, package manager, registry cleaners, and so on like that. That are very, key. Those are very key softwares. So let's go to what we call the operating system. Operating system. Operating systems are the core of a computer system. They are the core of a computer system. You can underline that or write that down. Operating systems are the core of a computer system. Operating systems are the core of a computer system. A software layer that abstracts away the messy details of hardware into a useful, portable, and powerful interface. What that statement means is that the operating system software, okay, brings your various hardwares together and makes them useful, portable, and becomes a powerful interface. So your hardware now becomes a powerful interface for you to use. So when we say your operating system is a core of a computer, without installing your operating system, the system will not work. It will never work. It's like when you buy a vehicle without putting the fuel, the ignition will not start. The ignition will not start. Okay, so the operating system is the core, the basics. So when you have a system, the first thing is to install the operating system before it can be powered. Okay, because it's when you on it, when you on your system or you power it, you see that it begins to boot. Your system boots either to Windows or it boots into Apple operating system. So the purpose of an operating system to manage physical resources. That is, it drives various devices. It ensures that every resources, every devices, every hardware are able to perform their function. Okay, the operating system ensures that all the devices, all the hardwares of a computer are able to perform their functions. Examples of those hardwares or devices are the CPU, the memory, disk, the networks, the displays, the cameras, and so on. So they do us work of efficiently, reliably tolerating and masking failures and so on. So it also provides an execution environment to the applications. It provides an execution environment to the applications running on them. That is what we are saying, that is running on the computer. So what we're saying is that programs like Word, Emacs, and CorelDRAW, Photoshop, all those application software, the operating system serves as a basis. It provides an environment for you to be able to install the application software. That means without you installing the operating system, there's no way you can even install your application software, because it is the operating system that will power your system, that will ensure all the devices communicate together with each other, like that. So it provides the environment. Then it provides virtual resources and interfaces. The operating system provides virtual resources and interfaces, e.g., it provides files, directories, users, spread, processes, and so on. Simplify programming through high-level abstraction. So the operating system simplifies programming through high-level abstractions. It also provides users with a stable environment. It's able to provide the users, you and I, a stable environment for us to work. So in totality, if we look at a system requires a whole lot of involves programming for it to be developed. Systems require programming for it to be developed. Now, they are basically how do I put it now? Programs are designed to ensure that these devices, machines that we have, okay, are able to perform their functions. And then we have, if you go back to when we were talking about the compilation, translators, and assemblers, we said that especially the assembler, we said understood to be a translator which produces machine language code as output from an input language, which is similar in structure to the output. Then we went on to talk about the compilation. It says it is the process the computer takes to convert a high-level programming language such as COBOL or Fortran into a machine language that the computer can understand. So when we talk about system programming, basically we are talking about how to develop a program that ensures that a system is able to perform its task that it has been meant for. So if you develop a machine, if you manufacture a machine, there is a task that you want the machine to perform. Now the basic thing for you to do is now to write a program that will ensure that that machine is able to perform its function that has been manufactured or created to do. Okay, and now the good thing is that we are in the era of artificial intelligence, where programs are based on artificial intelligence, and then the machines can even perform, tasks that are even beyond the regular machine performer. What we are saying here is that the what we are saying here is that now we have machines hardware that are developed to be able to perform reasoning tasks on their own. They can be able to reason and execute tasks on their own. Okay, so that is what the machine we now have now using artificial intelligence. That is why we have robotics coming into play, because robotics has provided a upgrade to what we call system programming. It has provided an upgrade because after you know the basics of our programming, you can see how all this machine language is there. But now we have a higher level of machine language that are even simpler, that are making this artificial intelligence to come into play, to work on it, to work. Okay, this time, which now makes machines to be able to reason and then act on their own. However, lastly, before I round up for this evening, we have processes, steps that are being followed, because for every system, there are steps that are to be followed. Steps and guidelines that ensure that the tasks are executed and performed the way they should be performed. Okay. Now there are stages that they follow, from input stage to compilation stage to interpreting stage to even the execution stage. There are stages. There are stages at which or steps that the program has to follow, and it's usually followed in a sequential order. They are followed in a sequential order or in a sequential format, as the case may be. Okay, so you have to follow a particular sequence. Any question before I finally round up? Do I have any question from any of you? Do I have any question? Is anybody with a question? Okay. I don't believe there is no question. We are all following through. That means we understood what we're saying. So I posted my email address, and I'm doing that again because your attendance is very compulsory. Your assignment is compulsory, and the next class I'm going to be giving you my first assignment. And the assignment will be based on what we have learned so far in these first two classes. Okay, and then in the last class, so I'll give you an assignment to finalize on Java for you to understand your basic knowledge, what you have been able to grasp so far in the course. And all these test assignments we put together, which will form part of your CA. I want to believe you have been well and fully briefed. Okay, so we will put all these assignments together to form part of your CA. Okay, so okay, we said there's no question. That means, which means we are all following through. Okay, let me see if I can okay, let me talk briefly on Java. Let me just introduce you to Java before the next class. Now, a Java program. Let me just talk briefly on Java program. The next, I think I have just like 5 minutes more. So, Java program. The Java program is one of the characteristics of a Java program is the fact that it's the most stable programming language. The most stable programming language is the only programming language that can run on almost any machine. You don't need a converter to convert or rewrite the program before it can function on any machine. Another good thing about Java is that it can function on its own. It can function independently. It can function independently. And when I say Java is a program that can function independently, what we're saying is that you can run the program without having to embed it in anything. You don't have to embed it in a browser. You don't have to embed it in the particular programming software or whatever. You can write it and it can function and give you a performance. And that is what we call a Java snippet. That's what we call Java snippet. And that is a Java program, part of a Java program that can function and execute on its own without having to embed it on any platform or on any program or in any software or in any browser. Okay, the Java snippet it can function independently. Writing a Java program is a very simple process. That's what we'll be looking at things like a class. We're looking at methods. We're looking at how to write a simple Java program known as the hello world. It is the most common part of it. Hello world is the most simple part of the most simple Java program. It's the most simple Java program that you write, which is hello world, and then we will interpret it. What does the program mean? All the things that have been written in the program, we interpret it for which one is input or which one means input. We have the print lane, which is the print on screen and the rest like that, or print list. We are going to be looking at the Java program, how to write it, how to run. We have the object, we have the class, we have the method. We'll be looking at them. We have variables too. So we'll be looking at all those things, their definition, how do they work, their definition, how do they work, what do they do, how do you put them together. Okay, we'll be looking at all these factors, and then we'll be looking at now in Java too. We have something we call encapsulation, encapsulation. Hopefully we should be able to look at that aspect in Java program too. Once again, let's see, just a minute. Okay, let me pull something out for us. I want to pull something out for us. Just a minute. Let's see. So I'm trying to hope, let's see. Okay. Just hold on. Let's see how it looks. Now, one of the things you also need to understand about Java is that Java is an object-oriented program. Java is an object-oriented programming language. And that's what we call OOP, object-oriented programming language. Now look at what I have on my screen here. This is a program. This is a Java program written here. And you can see how a simple Java program looks like. It says a program to display the message hello world. Now I mentioned the other. So the program starts from here. The Java program starts from public class hello world, public static void main, string. This is string. Now this args is called argument. The argument. Then we have the system.out.println hello world. Then you have to end of class hello world. You can see that now. So what it means is that the system, you can see it says the command that actually displays the message is system.out. So the message that will be generated or printed out is this command that is saying it. This system.out print is saying that the system, let me tell you the meaning of what we have here. As a plus for what I'll give you this evening. It says system output should print this line hello world. Did you get that now? This system should print an output on this line, which is hello world. So that is how a simple and typical programming language looks like. So we're breaking it down. All this program, you can see this is another example of a Java program. It's another example of a Java program. Okay. So this is variables and primitive types. We're looking at variables. What are variables? How does variables work? Okay. We're going to be looking at different types of variables. Then we have what we call types and literals that we'll be looking at. Okay. We have the byte, we have the short, int, long, float, double, clear, char, and boolean. Okay. They will sound grayish or Greek now, but by the time we end the class, you fully understand them. Okay. You fully understand what they are and how important are they in writing programs. This is a long program. If you look at what I have on my screen here, this is a long program. It's a long program. It says this class implements a simple program that will compute the amount of interest that is earned on 17,000 naira invested at an interest rate of 0.07 for 1 year. The interest and the value of the investment after 1 year are printed to standard output. So you can see the various commands that are being inputted on what and what to do. You have the variables being explained here. Double principal, value of the investment, double rate, annual interest rate, double interest and in the 1 year. So you have all the programs, then you have all the variables inputted with the actual value, and then you have what do you want it to do. The interest, you want to calculate the interest and principal and the rest like that. So the basic thing is just for you to understand the basics. When you understand the various tools that are being used in writing a Java program, it will be easier for you to write any program that you want to write. Okay, it can be easier for you to write any program you want to write. Let me see all the basic things we'll be looking at. It's almost time to round up. Well, I'm actually running up. Let's see. Okay, I think that will be all. Don't let me bore you. Let me bore you for tonight. That will be all. Okay, that will be all. Do I have any other question? Do I have any question? Okay, so expecting questions. We have less than 2 minutes. I'm surprised at this turnout. We have 13 students in this class, and this is a nationwide class. If your colleagues are not here, tell them they have to be online. They have to be online. The earlier they tap into this platform, the better for them. Okay. Okay. That'll be all for this evening. I'll see you next class in our timetable. Just go and prepare yourself. Go and read Java before the next class. Go and read up on Java. Okay. And then read up on what I've taken you so far. Like I said, I've sent my email address out. I need you to send me a chat on my email. Send me a message on my email so that and once you send me a message on my email, just tell me your level, the course, and your center. Okay, and tell me you need the material. So I'll quickly send it to you. Okay. So time up. We'll see you in the next session.